Welcome to the Sig Figs tutorial. Sig Fig is short for significant figures, and the word significant in this case actually means meaningful. If something's significant, it has meaning. It's not random, and it's meaningful. In this case, what's meaningful is that we've measured the number in question. So significant figures are numbers, or digits, if you will, digits or numbers that we've actually measured. Not all the numbers that we encounter every day in science class are actually measured numbers. Some numbers are what we call exact numbers. So for example, if I were to count the number of people in the classroom, that would be an exact number. That's not a measured number. There's no estimating going on there. I'm actually physically counting each person. So exact numbers are always what we call significant. We don't have to worry about it. But measured numbers, sometimes the digits that we get are meaningful and sometimes they're not. I'll show you an example. Take a second and look at the ruler on the bottom first. Let's say that this is a centimeter ruler and that 1, 2, and 3 are centimeters. Obviously, this is blown up bigger than real centimeters. I hope you realize that. So if I were going to use the ruler on the bottom to measure something and it came to where that dotted red line is, I would have to estimate that that's approximately halfway between the 2 and the 3. And so I would say that whatever this object is that comes out this far is about 2.5 centimeters long. Which of the numbers in this measurement are significant numbers, meaningful numbers that I actually measured? Well, certainly the 2 is significant because I know for sure I have at least 2 centimeters. But what about the 5? Did I measure it or didn't I? Well, you could probably argue either way, but for the sake of consistency, we allow you to have one estimate in every measurement that you get to count as significant and meaningful. You did in fact measure it. You didn't necessarily know exactly whether it was a 5 or a 4. It could be a 5, 4, or even a 6, right? Different people might see it differently. But we consider that a significant figure, a significant digit. So, which numbers are significant? When you measure, a digit is significant if you actually measured it, including one estimated digit. Now, if I were to use the ruler on top to measure the same object, I can get more information from that ruler. I can estimate out one more decimal place. That's because I have lines between my centimeter lines. So I now know for sure that I have 2.5 centimeters. I know I have at least that much because I can count. I can see that my red line is to the right of the 5th divider, and that 5th divider is right here. But I have to estimate how far I am between the next two, right? So I have to estimate that I'm halfway between those two. So now I have 2.55. How many significant figures are in that number? Well, all 3 are significant because I'm counting the second 5 as an estimated. I'm allowed to have that estimate. I'm allowed to count that estimated measurement. Okay, so it's pretty easy when you are the measurer. You can tell easily how many significant figures or digits you have. But if somebody else did the measuring, sometimes it can get confusing. Here are some rules for you, and you might as well take a screenshot of this, put it in a notebook somewhere. Maybe you can put it in your archive, anywhere you want. You can even copy this down and handwrite it and have it handy just in case you can't use your iPad for something or you don't want to, so that you can have these rules. When somebody else has done the measuring and you're looking at a number and you need to know which of these digits actually are meaningful digits and which of them are just really there to hold the place, this is what you do. You look at the number and you tell yourself, okay, if it's not a 0, it counts. Any number that's not a 0 is considered significant. That's the first rule. Plus, any zeros that are sandwiched or stuck or trapped between real numbers, those are also significant. So in this number here, the 3, 4, and 2 are all non-zero numbers, so they all count as significant digits. And the 3 zeros are trapped between the 3 and the 4, so they're also significant. So if I were to ask you how many significant digits, or how many sig figs for short, do you see in this number, you would tell me 6. On the other hand, look in the next rule. If there are zeros that come before any numbers, they do not count as significant measured numbers. They're just what we call placeholding zeros. All those zeros you see before the 3 and the 4 do not count as measured numbers. You didn't measure those numbers. They're only there to hold the place so that you know how far out you are in the tenths, hundredths, thousandths place. We're pretty far out here. So only the 3 and the 4 are significant in the second number. Likewise, trailing zeros sometimes are significant and sometimes aren't. It depends. Look at the number. If there's a decimal point anywhere in the number, all the trailing zeros become significant. Because really, if you think about it, in this number here, there's no reason to write those 2 green zeros except to point out that, hey, I measured them. So the leading zeros that come before, the black ones, they are not significant digits. They're just there to hold the place. But the green ones on the end, the only reason for you to have written them is to tell the person that's reading the number, hey, look, I measured out this far and there was nothing there. There's a big difference between those two things. So in that number, you have 4 significant digits. Finally, if there is no decimal place anywhere in the number, then all the zeros that trail at the end of numbers suddenly become insignificant. You may have measured them, you may not have. You don't know unless you're told. So for example, in this number, 190,000, we don't know if those zeros are there just to hold the place or if they're there because we actually measured those spots and there was nothing there. If we had a ruler that could measure out that far and we actually measured all of those things, the best thing to do would be to put a line over all the zeros that are significant so that people would know, okay, yeah, we measured all those places and they are all exactly 0. These rules you will start to internalize and memorize without having to actually memorize them, just by practicing. So what we're going to do in class when I see you next is you're going to practice figuring out how many significant digits there are in a number, and you're going to be allowed to have the rules in front of you just like training wheels until you get so used to them that you don't need them anymore and you'll be able to throw them away. But this takes a lot of practice. So I'll be giving you lots and lots of practice to do this with, and when you get really good at it, I'll show you what to do when you have to calculate with 2 or more numbers and where you're going to round using these rules. See you in class.